Let's take a look at this review problem. Let n be a positive integer, and suppose that 2 to the n minus 1 happens to be a prime number. This is called a Mersenne prime. For example, if n is equal to 3, then 2 to the third minus 1 is equal to 7. 8 minus 1 is 7. Another example, if n is equal to 2, then 2 squared minus 1 is 3. That works. If n is equal to 5, then 2 to the fifth minus 1 is 31. That also is a prime number. It doesn't always work out that way. If it happens to work out that way, then we call that number a Mersenne prime. The first part is to list out all the factors of 2 to the n minus 1 times p. So the n is equal to 2 to the n minus 1 times p to the first. And so by one of the theorems we have from class, the factors are going to be everything that's a power of 2 times a power of p. So 2 to the I times p to the j, where 0 is less than or equal to I, less than or equal to n minus 1, and 0 is less than or equal to j, less than or equal to 1. So power of 2 times power of p, where the exponents I and j must be less than or equal to the respective exponents in capital N. So if I just list them out, it'd be 1, 2, 2 squared, up to 2 to the n minus 1, then p, 2 times p, 2 squared times p, up to 2 to the n minus 1 times p, which of course is the original number, capital N. Okay, now let's add all these things up and show that if I add all these things up, I get 2 times capital N. So capital N itself is right here, and therefore the sum of all the other factors would be equal to capital N. So to do this, to add these up, so we have the sum from I equals 1 to n minus 1 of 2 to the I. And we also have, for these terms, the sum from I is equal to 1 to n minus 1 of p times 2 to the I. So clearly I can factor out 1 plus p times the sum of I equals 1 to n minus 1 of 2 to the I. Now remember, p was assumed to be equal to 2 to the n minus 1. And to do this sum, we use the formula for a finite geometric series. This is 1 minus 2 to the common common ratio is 2. So 1 minus 2 to the number of terms plus 1. So 2 to the n. Sorry, the number of terms plus 1. So that's n. Minus 1 plus 1 for n over 1 minus the common ratio, which is 2. So this is equal to 2 to the n. Then here I have 1 minus 2 to the n over negative 1, which is 2 to the n minus 1, because I'm to just divide by negative 1 is the same as flipping the sign. So that's equal to 2 times 2 to the n minus 1. And notice that 2 to the n minus 1, again, that's equal to p. So that's equal to 2 times capital N, which proves that the number is a perfect number, that if you add up all the factors, you get 2 times capital N.